Again to another set of notes on chemistry. We're looking at percentage error and graphing. But right now, percentage error. Percentage error is defined as the way of determining the accuracy of a value, and the equation we use is the absolute value of TV minus EV all over TV times 100 is percentage error. TV is a true value. EV is called the experimental. In other words, TV is what it's supposed to be. Experimental, what you come up with in the lab. All right. So, and just so you know, acceptable error is considered less than or equal to 10%. Alrighty. So here's a problem. Copy it down. Ready? So we'll find the density here first, where density is unknown, mass is 9.75 grams, and volume is 10.0 milliliters. Put our values into the equation. Our density is 0.975 grams per milliliter because of sig figs and all that kind of stuff, which means our experimental value is 0.975 grams. What's the TV? Well, the density of water, if you remember, 1 gram of cubic water is 1 cubic centimeter, so therefore 1 gram is 1 milliliter, the same thing. So put our equation, put our values in, and remember that 1 gram is infinitely significant, so we don't worry about sig figs by subtraction. So we get 2.50%, which would be considered acceptable, and that's my answer. All right. Here's a problem for you to copy down. We'll do together in class. All right, graphing. Graphing is defined as means of representing data in a pictorial form. And in order to do that, we need to understand two things, independent variable and dependent variable. Independent variable is a variable that you control. Dependent variable results from the process. In other words, what you're actually deciding what you're going to measure is the independent, and what comes back out of that is the dependent. When we do this, a certain process we have to remember, the origin does not have to be 0, 0. It can be, it doesn't have to be. And sometimes if you want it, really have to have it, we can use a squiggly line to separate it up. We make graph take up at least half the graph surface. Why do we do that? Because we don't want to leave empty space. All right, show data points with geometric shapes. What do we mean? If I've got a point, I want to put a geometric shape around so I know that's not a straight mark, and also to have some room for error. Draw the graph. There are two ways we can do that. Either exact fit or best fit. Exact fit is point to point. We really don't do that much. Exact fit. Best fit is rather you take the points and using a line of best curve, something like that. Should be a little bit more curve along that lines. Okay. All right, so also last thing we have to do is remember to title the graph, which is dependent versus independent. I'm going to put my line back in. Alrighty, okay, it's not going to be in the rest, but that's where it's at. All right, good. So let's take a look at some data points here. Let's say I had a data where distance is 5, 10, and 20 meters. The time is 6.25 seconds, 12.5 seconds, and 25 seconds. So we put our graph in. Our distance is our independent, so it's our x value. Time is our dependent, it's our y value. I'm going to use every line as 5, so 5, 10, 15, 20. And I'm going to make it 0, 0. You don't have to, but I'm going to. So every line here is also 5. Put our first point in, and remember we want a geometric shape around that. So that's 5 and 6.25. That's 10 and 12.5. And that's 20 and 25, line of best fit. And time versus distance, dependent versus independent. All right. Here's a set of data that we're going to do. We're going to do this one together, and I'll give you the problem in Google Classroom inside the book. You don't have the book. And then these are two more we'll do afterwards. All right? Hopefully that wasn't too bad. Take care. Be good. Bye.